Let's talk about work now. When a constant force is applied to an object, so the object moves in a straight line from point P to point Q, the work done by the force F acting on an angle theta, the line of motion is given by W equals F dot PQ vectors, or the magnitude of F times the magnitude of PQ times cosine theta. Okay, that's what work equals. So it could be either one of those two here. So let's take a look at this problem below. It says you are pulling a wagon with a force having magnitude of 12 pounds on the handle at an angle of 45 degrees. If you pull the wagon 62 feet, find the work done by the force. So what we're going to do here is we're just going to set up a diagram for this. So I'm going to draw a wagon, and I'm going to draw a vector coming out, and that's going to be my 12 pounds. And I'm also going to draw an angle here. I'll be pulling it straight, and this angle is 45 degrees. So that's what we're looking at here, and we're going to pull this wagon, and I'm going to use this bottom vector for that. So I'm going to take this one away, and I'm going to make it longer because we're going to go 62 feet. What we're going to do is we're just going to find out how to calculate this, and we're going to use this formula above for this. Now keep in mind, if I'm looking at my vector PQ, now remember what that was. That's so the object moves in a straight line from point P to point Q, and that's going to be my vector PQ in that direction. So this magnitude of PQ is going to be 62 feet for this problem, because that's the distance being traveled, that straight line moving from P to Q. Okay, so that's going to be 62. So all we're going to do is plug in our information in this handy dandy formula. Now I'm going to use this one here because I have F and I have the magnitude of PQ, and I also have the cosine of theta. Very simple, very straightforward. I don't have the vector PQ or the vector F, so therefore that's why I'm not going to deal with that one. But I do know the magnitude of F, so that's why I'm using this one here. The information is very straightforward if I do. Here, I would have to know each vector, and then I can use just a simple dot product. So that is another use for the dot product, is finding work. So work equals the magnitude of F, which is 12 pounds, times, and I'll just use parentheses, the magnitude of PQ, which is 62, and we have the cosine of 45 degrees. So this here is going to be my work. So this equals 744, and that's 12 times 62. And the cosine of 45 degrees is actually root 2 over 2. So if I wanted an exact answer for this, I could get it. And that exact answer would be 372 root 2, because this 2 and 744 would cancel, and this would actually just be 372, and that would be 1. So this would be the exact answer, and I'm talking about a work being done. So my units would be foot-pounds, or my approximation would be approximately 526.087 feet-pounds. So there's our answer.